Algebra 2 Honors 3.4b, using the quadratic formula. And we're going to be looking at the discriminant, and that discriminant is that b squared minus 4ac that is underneath the radical. I'm going to just highlight it, I guess. That b squared minus 4ac is called the discriminant, that value underneath the radical in the quadratic formula. And if it's positive, 0, or negative, it tells us something about the nature of the solutions. And then we're going to see some applications involving the gravitational pull, objects being thrown up in the air or down, or thrown straight parallel to the ground, and work with a quadratic equation that we develop with those pieces of information. So anyway, the discriminant. Now, just think about it. If you're starting to solve, and you get x equals 2 plus or minus the square root of a negative 5 over 6. Right there, because you have a negative under the radical, you're going to have imaginary solutions. And that b squared minus 4ac in that case is negative 5. And when that is negative, that's less than 0 is a fancy way of just saying that it is negative. That means you're going to have imaginary solutions. So by knowing that the discriminant is negative, you're going to have two imaginary solutions. Versus if you have x is equal to 4 plus or minus, and you get the square root of 0 over, say, 7, that boils down to just 4/7. And you have only one solution. And so that's when the discriminant, the b squared minus 4ac, was 0. You ended up with one real solution. And then when the discriminant's positive, you end up with two real solutions. So that's what this says right here in this core concept. In this first one, when b squared minus 4ac is greater than 0, that's just a fancy way of saying it is positive. You're going to have two real solutions. And graphically, that means we're going to have two places that this parabola intercepts the x-axis, because they are real values where it crosses. However, when the discriminant is 0 in this middle case, what happens is that parabola is touching the x-axis in just one spot. Whether it's opening up or opening down, the vertex is on the x-axis. For example, maybe this is y is equal to x plus 1 quantity squared, where it's shifted to the left 1. And so if I wanted to know where that was 0, since it's the same quantity, it just ends up that x equaling negative 1 would be the place where it crosses, and it's the same root because it's the same factor repeated. And so that's where you're going to get a discriminant that is 0. And it means you will have one real solution. You're going to be asked to find the value of the discriminant, and based on that, tell me the number and type of solution. So your answers are, you find the value. If it's positive, you're going to give me that value and write two real solutions. If the discriminant comes out to 0, then you're going to say the number and type of solutions, and your answer is going to be one real solution. And if that discriminant comes out to be negative, then you're going to say that there are two imaginary solutions. And graphically, that parabola does not touch the x-axis ever. So either it is above the x-axis and opening up with no chance of hitting the x-axis, or it's below the x-axis and opening down with no chance of crossing the x-axis. So the value of the discriminant gives me an idea of the number and type of solutions I should expect. All right, and then just a concept summary over here. Methods for solving quadratic equations that we've had. We've done it by graphing, using square roots, by factoring, by completing the square, and using the quadratic formula. And here are the hints of when to use them. And so this is a nice little chart that summarizes, because you want to be fluent in all of these methods. The nice thing about the quadratic, it can be used on any quadratic equation to find the zeros, the roots, the solutions, but sometimes it's not the most expedient. And so you want flexibility, you want other options. So in example 4, there will be problems like this in your homework. It just says find the discriminant and describe the number and type of solutions. So we're looking at b squared minus 4ac. Now note that it needs to be in that form of ax squared plus bx plus c equaling 0, so that this is all set equal to 0. So anyways, the b value is negative 20. Minus 4 times the a value is 25, and the c value is 4. And so that is equal to, and then we have 16 quarters. And 4 times 4 is 16, and 16 sets of 25 would be 400. And so we have 0. So that's the value of the discriminant, right? Find the discriminant and describe the number and type. So you can go right up here, and it's going to be one real solution. Just off the value of the discriminant. So again, in this one we have the b squared is going to be 2 squared minus 4 times 1 times c. So I need to at least see this step so I know that you've identified b, a, and c correctly. Answers only are not acceptable. And so you get 4 minus 24, which is a negative 20. So that's the value. And since it's negative, it's 2 imaginary solutions. And in part C, again, the b squared minus 4 times a times c. I need to see that. And we get 16. So that's the value of the discriminant. And when it's positive, that means we have 2 real solutions. Kind of a powerful thing, the value of the discriminant. It's a good thing to use, especially if you're trying to factor something and you're like, does this really factor? You can quickly check the value of the discriminant. For example, right here, right, if I did the x equals a negative b plus or minus, that discriminant, b squared minus 4ac, was 16 all over 2 times a. So when you get a perfect square, that means this would be x is equal to negative 2 plus or minus 4 over 2. And so that gives you 1 and negative 3. And when that discriminant's a perfect square, that means that this would have factored. It's a good thing to know. And so factoring would have been a good thing to use on that in order to solve. And I know that not because the discriminant, not only was it positive, but it was a perfect square. All right, so number 5. Find a possible pair of integer values for a and c. So this has one real solution. Well, it's in quadratic form. Then how we started the lesson was the discriminant, and by the value of the discriminant, we know if there's one real solution, 2 real solutions, or 2 imaginary. So you should make that connection. So if I want one real solution, what do you know about the nature of the discriminant? Well, the discriminant must be 0. That's from this chart up here. You get one real solution when the discriminant is 0. So that means I want b squared minus 4ac to be 0. And that's what you should set up. So I'm going to rewrite that here. So my b squared is a negative 12, and you need the negative inside the parentheses with the square on the outside. Do not do this, and then write 144, because that's not true. The value of this is a negative 144, not a positive 144. So if you want to communicate it correctly and have the right math, for it to come out to a positive 144, the negative needs to be inside the parentheses, so you're taking a negative 12 times a negative 12. Without those parentheses, you're going to see this on your test. I'm going to take off points. And they have to be correct where the square is on the outside. And if you're missing them on a negative, you're not going to get credit for that, or you'll lose points for communication. All right. So then we have minus 4 times, well, oh, wait. The coefficient of x squared is a variable. Wait. The value of c is just c. That's a little abstract. So I have 144 minus 4ac equals 0. I'll continue to go. 144, let's put the variables on the other side, divide by 4, and 8 times c, 4 goes into there 3 times and goes into 24 6 times. Well, we're used to where you get down to x is 5, x is negative 2, x equals. Here I have 8 times c is 36. There are several answers. You need any two values you choose to pick that multiply to be 36. You can use 1 and 36. You can use 2 and 18. You could use 1/2 and 72. Although I'd probably avoid no, you can't, because it said integer. My fault. Nope, you can't use 1/2 and 72 because it said integer. So I'm just going to choose, let A be 4 and let C be 9. And that might not be your choice. So there are a variety of answers possible. And so now I need to go back in, because it says write the equation. And when it says equation, if you don't have equals, you're not going to get credit. So if I go back, ax squared would be 4x squared minus 12x, and then plus c, so c is 9. And if you stop there, no credit, because an equation needs to have an equal sign there. And there is one possibility. There are several. You will be asked to, do that for 2 real and 2 imaginary, and you're going to do the same kind of thing. More than one expression is possible. All right, now we're going to get into an application where when an object is dropped, we have an equation h is equal to negative 16t squared plus h naught. And that's when you just hold the object and you release it without throwing it down. You just have your hand, it's in your hand, you open your hand, and you just let it drop. So there's no velocity with which you're pushing it downward. On the other hand, if you are throwing an object either up or throwing the object down, the object is launched or thrown, then we have an initial velocity. And by the way, h naught is initial height. At time 0, h naught is initial height. And so v naught is initial velocity. And if it's thrown up into the air, then your initial velocity is going to be treated as positive. If it's thrown down, then your initial velocity is going to be negative. If it's thrown parallel to the ground, then we're going to treat initial velocity as 0. And I'm going to scroll because I copied that out of the book, but I put it on the next page. And it summarizes this all here. And so when you just drop an object, here is your equation. But if you launch or throw, then we have to add this extra term of v naught times t. And that's right there. And this is only for height in feet and time in seconds. It is due to the gravitational pull of the Earth. And we have different values if it's on different planets, by the way. So anyways, and then right here they try to go through. The initial velocity can be positive, negative, or 0, depending on whether object is launched upwards. So if it's launched upwards, it's positive. If it's launched downwards, negative. And when it is 0, or launched parallel to the ground, it is 0. So you need to keep that in mind because you're going to have to choose the correct sign for your initial velocity. So let's look at the example. So the juggler tosses a ball into the air. So he's tossing into the air. It leaves the juggler's hand at 3 feet above the ground. That's your initial height. It's in feet, and that's your initial height. And then it gives an initial velocity of 20 feet per second. Should it be positive or negative? Well, it's tossing it into the air, so that means the juggler's tossing it up into the air. And so velocity should be positive. And then the model that you need to use on this is, I'm going to write it as h of t is a negative 16t squared, and then use your plus 20t and then your plus 3. This is the model. Oops. This is the model we want to use because the object is launched or thrown. It's not just dropped. So we need that initial velocity in there. And then it says the juggler catches the ball when it falls back to a height of 4 feet. How long is the ball in the air? Well, I want to find out at what time the height is 4. So this is what I need to solve. The time for which the height is 4. So now pretend like that was your original equation and solve. Subtract 4 and get it set equal to 0. It needs to be set equal to 0. Can't emphasize that enough. And 3 minus 4 is a negative 1. You need the 4, you need the 0 equals. If you just have that, that's not an equation to be solved. It needs to equal 0. And we're going to go ahead and use the quadratic equation to solve. And in this case, it's not x equals, the independent variable is t. So we get a negative b plus or minus the square root of a negative 16 squared is 256, minus 4 times a negative 16 times a negative 1, all over, and I should see that step where you're breaking up the discriminant, and I know what you're using for the b squared, the a, and the c. And then all over 2a, and 2 times a negative 16 is a negative 32. And then it'd be okay to use your calculator to get the value for underneath the radical. And so we get 336. You should be able to do it without a calculator, but it's okay. And then do not reduce anything as is. You can't. It'll be wrong. You have to have something out in front of the radical that has a common factor with 20 and 32. And right now there's only a 1 out in front of the radical. So you can't simplify that like that right now. Now the 336, if you add up the digits, you get 12. And since 12 is divisible by 3, 336 is. So the latter method of factoring, and then if I add 1 plus 1 plus 2, I get 4. Oh, so that's not going to work. And I guess I should have started with 2. Oh well. So if I put 2 in there, it goes in there 5 times into 12, it's 56, and then 2 goes into 56, 28 times, and 2 goes into 28, 14 times, and 2 goes into 14, 7, and you're done because that's prime factored. And so for every pair, you can take 1 to the outside. So that means the square root of 336 is 2 times 2 times the square root of the loners. 3 and 7 are loners. You multiply those and put those underneath. So you have 4 root 21 for the square root of 336. So back over here, I have a negative 20 plus or minus 4 square roots of 21 all over a negative 32. Okay, I'm liking that because the 4, the 20, and the 32 are all divisible by 4. So I'm kind of out of room to the right. I wrote too much stuff. I don't normally do this, but I'm going to come back up over here. And then I've got t is equal to, now notice though how I'm communicating. It's not my normal to go to the left, but I'm working straight down the middle. And then when I got to the bottom and around, I'm going to start another column, and I'm showing with the arrow where I'm going. In the numerator, I can take out a 4. And now the 4 and the 32 reduce to a 1/8. Oops. And so that answer is fine. However, if I multiply the top and bottom by a -1, it's probably more traditional that they'll have the 5 be positive, and the plus and minus, 1 changes to negative, 1 changes to positive, so it still is just plus or minus. But then in the denominator, we have a positive 8. So underneath the radical, I don't like the way that looks. I don't like that either. And so it's just going to be more traditional to write it with the 5 and the 8 positive. And so how long is in the air? Oops, I started circling that. We're not quite there yet. I really didn't give myself enough room. Because what you need to do now, I'm just going to work on to what is my second page, is break it up and get out your calculator. And make sure you add the 5 and the root 21 before you divide by 8. You should practice it. And to 2 decimal places, you get 1.20 seconds for that. And if you do the t equals 5 minus the square root of 21 all over 8, and evaluate that, I don't have the decimal value for that. Let's see. I thought I had it all written out. I'm just grabbing my calculator. I don't have it. And I'm evaluating it. 5 minus square root of 21. And divide by 8. And we have 0.05 seconds. And I thought the answer was 1.20 seconds. Let me see. So I'm just going to check my work here real quick. And I am looking. And this is in 3.4. And I'm looking for where did I get this example. Oh, okay. So here I can explain this. I got it. So what happens is the juggler is at 3 at the start, and he's got this parabola of what's happening with this. Of course, he catches it at 4. And so if this is at 4, and if I draw a horizontal line, he catches it at a height of 4, and that's the time we want. So this first time of 0.05 is when, after he releases it, it hits the height of 4 on the way up. And so it is just the second time of 1.20 seconds that is the answer, because that's when he catches it on the way down. So in context, it is at 1.20 seconds. All right. Okay, good thing we got to that and got a discussion on that, and I could explain why that happens. All right, so then I just wanted to highlight, in the beginning of this, I have some questions about why is initial velocity positive, negative, and why is it 0? So I just copied the problem 61, 63, and 64 so we could just talk about this. And so in 61, tosses it from an initial height of 7 feet. So that means h naught is 7. Has an initial vertical velocity of 90 feet. So they are throwing the ball in the air, and so it's going up. That's going to be velocity is positive, so we're going to use a positive 90 for velocity. And then plug that into the equation. And then that equation is going to be that h is a negative 16t squared. Oops. And so for this one, yeah, that negative 16t squared, and then velocity is positive because it goes up in the air, and you have an initial height of 7, and then continue, etc., with that problem. And then in 63, and a volleyball player spikes the ball over the net when the ball is 10 feet above the court. So there's your initial height. And the spike drives the ball downward with an initial velocity of 55. And since it's going downward, the velocity in the equation has to be negative. So you're going to get initial height of 10. And so h of t is going to be the negative 16t squared minus 55t plus 10. And then continue from there. And then last, the 64. An archer is shooting at targets. So notice how it's starting by shooting parallel and then it's falling. They're trying to say that it's starting to go parallel to the ground. The height of the arrow is 5 feet. Due to safety rules, the archer must aim the arrow parallel to the ground. So they kind of create the problem to fit that other piece. And so in this case, because that's true, your initial velocity is 0. And when your initial velocity is 0, that really goes to this top equation, h equals a negative 16t squared plus h naught, because velocity is 0. Now, if you put that into the bottom one, it'll end up with that top equation. But then you're just going to be using h of t is that negative 16t squared plus your initial height, and you can work that out for yourself and work it from there.